Welcome to the lesson, How are Mass and Volume Measured? In this lesson, you are going to investigate how properties such as mass and volume can be found.
Hi guys, I was going to say hi, but it started talking before I could. So today we're doing lesson 3, what physical properties can we observe? So we're going to do 2 experiments on the online book to figure out mass and volume of rocks. This slide does not work. I've tried it like 7 times. It just doesn't want to work. So if you would like to do some research, be my guest, because it's asking us, which do you think has a greater mass, an African elephant or a pickup truck? So you can figure out how much both of those weigh, because that's the mass of them, and let me know what you figure out, or just tell me your guess if you want. I would like to hear what you figure out.
Besides mass, another property of objects that can be measured is volume. Volume is the amount of space an object takes up. Which object in each pair has the greater volume? Click a picture to discover more. Assume that objects in each pair are the same height.
So we're trying to figure out which one has the greater volume. And then he reminded us that volume is how much space it takes up. So it's not which one's heavier, which one has more mass. It's which one takes up more space. So in that first picture, we have a bunch of coins or a tennis ball. So the best way to think about this one is pretend like you have a tennis ball in one hand and coins in the other hand. If you're trying to close your hands into a fist, which hand can you close more than the other hand? Can you close the hand with coins in it better than the tennis ball, or the tennis ball hand better than the coin hand? You should be able to close your hand around the coins easier because they take up
Well
less
done.
space. They have less volume than the tennis ball.
Well done.
You can also look at the 2 pictures in the green squares, and the tennis ball fills up the green square a lot more than the picture of the coins does. And they said they're about the same height, so the stack of coins and the tennis ball are about the same height. But the tennis ball is just bigger and more circular, so it takes up more space, it has more volume. So pair 2 is a little teddy bear and a robot. If you look at the pictures, the teddy bear takes up more space in the square, and if you're thinking about a stuffed animal and a plastic robot, or I guess it's metal, the teddy bear or your stuffed animals probably take up more room in your toy box.
That's
than
right.
the robot or your other toys do.
That's right.
And then in the third picture, there's a liter of milk and a pillow. I mean, just looking at the pictures, you can see that the pillow takes up way more space. So it probably has a greater volume. Not mass, so it's not asking again, it's not asking which one's heavier, it's asking which one
That's
takes up
correct.
more space.
The ball takes up more space than the metal coins, so it has the greater volume. The teddy bear takes up more space than the robot. The pillow takes up more space than the carton. In this activity, you will find and compare the mass of several rocks. Here is your experimental setup. A balance, 1 gram and 10 gram weights, 5 different rocks. You'll calculate and compare the mass of these 5 rocks and record your data in the table.
So a balance, again, you should have read about it in the first section of this unit, is this gray thing right here. And it's a balance because there's 2 trays on both, like 1 tray on each side. And the whole point of it is to balance, so make both sides level with each other. So this middle thing with the little green dot lights up, and the red point is pointing straight up in the middle, which means both sides are equal. Then these little gold things over to the side are weights. So they weigh a certain amount. So if we put them on, we know exactly how much weight we're putting on. And then obviously we have our 5 different rocks. And the whole point of this experiment is to figure out which rock is the heaviest and which is the lightest. So we're going to rank them 1 through 5 in their weights.
What is your prediction? Which rock do you think has the greatest mass? Which rock do you think has the least mass?
Drag the rock you think has the greatest mass.
Drag the rock you think has the greatest mass.
I am going to pick rock 1 because I feel like it looks like it's really squished together and made out of a lot of tiny rock pieces that have been
Repeat the
crushed
steps
down
for the rock you
for
think
very
has the
long
least
time.
mass.
Repeat the steps for the rock you think has the least mass.
Then rock 3 looks like it is made out of volcanic ash. So remember when a volcano erupts, the lava can come out and then it hardens into a rock. And if it hardens quickly, it has lots of holes in it, which makes the rock lighter.
Continue
So I think
to see
this
if your
is
prediction
probably
is
the
correct.
lightest rock.
Continue to see if your prediction is correct.
Find which rock has the greatest mass and which rock has the least mass. Arrange the images in order to show how your investigation will be carried out.
Here are the steps. First, I'm going to start with an empty balance. Then I need to put the rock on. Then I'm going to add weights.
That's right.
Until both
When
sides
finding
are
the mass of one of the rocks, start with an empty balance. Add the rock to one of the trays. Add weights one at a time until the pans are balanced. You may need to take away weights to make the pans balanced.
All right, let's do the experiment.
Let's measure the rock's masses. Drag a rock to the scale.
Drag weights to the other side until the green light shows the trays are balanced.
I'm going to start with the 10-pound weights because I have to use less of them. So if I wanted to make 10 pounds, I'd have to put 10 of these ones on there to make the same amount of weight. So I'm going to use 10s until it looks like it's getting close. So I'm almost to the middle. So now I'm going to use the 1-pound weights until I get to the center.
You may need to remove some weights and add others to make this happen.
Total the weights and type it into the table.
So I'm going to count by 10s for the 10s. 10, 20, 1, 2, 3 for the 1. So 23 grams.
Repeat the steps for the other rocks.
And do the next one.
Repeat the steps for the other rocks.
Rock 2. Let's put 10s on until we get close to the middle. All right, I'm going to start using 1s now. Uh-oh, there we go. Okay, so I have 10, 20, 30, 40. 1, 2, 3, 4, 5. I have 45 grams. A reset. Come on. There we go. I'm going to start with 10s. Alright, I'm very close to the middle, so I'm going to put 1 on. And that's all I needed. So 10, 20, and then 1. So 21 grams. Reset. Let's do rock 4. 10, 20, 30, 40, 50. 2 grams. Reset, and let's do the last rock. $10, $20, $30. I'm gonna do ones now. 1, 2, maybe 3, 4, 5. So 10, 20, 30, 1, 2, 3, 4, 5. 35, whoops, 35 grams. All right, so let's look at all of the measurements over here. So it looks like I was right, and rock 3 was the lightest because it's 21. Whoops. And then rock 1 is the second lightest, so I was not correct with that. So it's 3, and then 1, and then number 5 is 35 grams, so that's the next lightest. Then number 2 is 45 grams, so the next heaviest or lightest. And number 4 is the
Now you can analyze your results. Which rock has the greatest mass and which has the least mass? Put the rocks in order from least to greatest mass. Enter values from 1 to 5 in the table. The rock of least mass gets a rank of 1. The rock of greatest mass gets a rank of 5.
So the one that was the lightest was rock number 3. Then it was rock number 1. Then rock number 5. Then rock number 2. And then the heaviest is rock number 4.
Let's see what you learned. Which rock has the least mass and which rock has the greatest mass? Drag your answers into position.
So this slide doesn't want to work either, but we just did that on the last page, and it was rock number 3, then rock number 1, then rock number 5, then rock number 2, and then rock number 4 is the order. But it won't let us do that. So we're going to move on to page 10 and do the volume of the rocks.
You have seen how the mass of these rocks can be measured. Another property you can measure for the rocks is volume. Remember, volume is the amount of space an object takes up. Make a prediction. Will the rock with the least mass also have the least volume? Click yes or no.
All right, let me refresh and see if it shows up.
You have seen how the mass of these rocks can be measured. Another property you can measure for the rocks is volume. Remember, volume is the amount of space an object takes up. Make a prediction. Will the rock with the least mass also have the least volume? Click yes or no.
So when we did the first, or I guess the second slide, where we had the like tennis ball and the coins, we said that whichever one takes up the most space has the greater volume. So I think rock 2 looks like it's smaller than rock 3. So I don't think that rock 3 is going to have the least amount of volume.
Continue to see if your prediction is correct.
No.
Continue to see if your prediction is correct.
Use the beaker of water to measure the volume of each rock. Let's start with rock 1.
Record the starting volume of water in the beaker in the row for rock 1.
Okay, so the water is right at 40 centimeters cubed. or cubic centimeters. You can say it either way. I can't make the little 3 on here, so I'm going to put a big 3, but 40 centimeters cubed, or cubic centimeters. All right.
Let's see what you
Next.
found.
Let's see what you found.
Use the beaker of water to measure the volume of each rock.
Use the beaker of
Let's
water
start with
to
rock
measure the
1.
volume of each rock.
Record the starting volume of water in the beaker in the row for rock 1.
Volume of water in the beaker in the row for rock 1.
Drag rock 1 into the beaker. Record the ending volume of the water in the row for rock 1.
The ending volume of the water in the row for rock 1.
All right, so it's above the 50 and below the 60. So let's see how many little lines are in between. 1, 2, 3, 4. So it's counting by 2. So 50, 52. So it's right at 54 cubic centimeters.
Subtract the starting volume from the ending volume to find the volume of rock 1.
The ending volume to find the volume of rock 1.
So I'm going to go get I'm going to open up the notebook so that we can write down our problem and do our math. So it was 54 minus 40. Four minus 0 is 4. 5 minus 4 is 1. So the volume of that rock was 14 centimeters cubed or cubic
Click Reset
centimeters.
to remove rock 1 from the beaker.
Click Reset.
Repeat the steps for the other rocks.
Repeat the steps for the other rocks.
So the water went back to 40 cubic centimeters for rock 2 because there's nothing in there to change the volume. Oops. Rock 2. Alright, so it's above the 50 and it looks like it's right about at that first line, so I'm going to say 52 centimeters. Cubic centimeters, so we need to do 52 minus 40. Two minus 0 is 2. 5 minus 4 is 1. So this one, rock number 2, is 12 cubic centimeters. Oops. Reset. Rock number 3. Whoops, I guess I should have double checked. So it is at 40 centimeters again. The water is at the same spot. Now let's put this rock in. And we are right in between the two lines. So I'm going to say 52, 54, 56. I'm going to say 57. Now remember, it's hard to tell exactly where the water is. So if you looked at that and you thought it looked closer to 58 or 56, I would take either of those answers as well. But I'm going to say it looks like it's kind of in the middle, so I'm going to do 57. So we need to subtract 40 from 57 because we need to find the difference between the heights of the water. 7 minus 0 is 7. 5 minus 4 is 1. So this rock number 3, is 17 cubic centimeters. Let's reset. We're back at 40 again for the next rock. Then we're going to put rock 4 in. And we're all the way up to, looks like 72. So then we need to do our subtraction. So 72 minus 40. 2 minus 0 is 2. 7 minus 4 is 3. .32 cubic centimeters. And rock number 5. We started at 40 again. This box is in the way. So we're going to put the height is 62, 64, 66. So we have 66 cubic centimeters now. Then we need to do 66 minus 40. 6 minus 0 is 6. 6 minus 4 is 2. So we have the rock number 3 is at 26 cubic centimeters. Reset.
Let's see what you found.
Go on
Which
to
rock has the least volume?
What you found.
Click the correct answer.
Has the least volume. Click the correct answer.
All right, so we have 14, 12, 17, 32, and the last one was 26. So
You got
the
it.
smallest one
Rock
is
2
rock number
occupies the least number of cubic centimeters, so it has the least volume. You found that rock 2 has the least volume, but it does not have the least mass. For a group of objects, the object with the least mass is not necessarily the object with the smallest volume.
Is not necessarily the object with the smallest volume.
So we were right with our prediction of no, because rock 2 is lighter. Rock 2 is heavier than rock 3. But rock 3 has a greater volume than rock 2.
In this lesson, you've learned a lot about measuring mass and volume. Before we finish, let's take a quick look at the main points you covered. The mass of an object can be measured using a balance and some known masses. Mass is measured in units such as grams and kilograms. The volume of an object can be found by measuring the change it causes to a known volume of water. Volume is measured in units such as cubic centimeters, milliliters, and liters. Now that you've finished the lesson, click the Lab Report button to save or print it.
Click the Lab Report button to save or print it.
In the lab, it never told you what the real name is of what we did to find the volume of an object, but that is called water displacement. So to find the water, or to find the volume of an object, you see how much water it displaces, so how much water it moves out of its way to take up the space. So, like if you filled your bathtub up with water, like all the way to the tippy top, and then you sat in the bathtub, the water, some of it is going to overflow off the sides because you take up space in the bathtub now. So the water has to get out of your way. So it goes off and out of the bathtub. So that is displacing the water, so getting the water out of your way. So that's what we're doing in the beakers with our rocks. The rocks are like you in the bathtub, so they're making the water get out of the way. And since there's more room up at the top of the beaker, the water is going to rise up to the higher spot because the rock is making it move out of its way. And that is all you have to do for science today. I guess that's not really true. You do have to take the lesson 3 quiz. So take the quiz, use your book and the video to help you. And